All right, guys, we've talked about tangents a little bit before, but today we're going to show some of the things they can tell us about circles and lines going through them. First, it says name some of the stuff. This is just review. Name a tangent. Well, we have a tangent line. Looks like it's the one right here that touches the circle at T. This is a line. I'm going to call it tangent TX. The point of tangency, where that tangent line touches the circle, is at point T. Then it says a point on the interior. Remember, that's on the inside of the circle right there. Well, there looks like there's two of them. There's the center P, or we could use point I. And then it says a point in the exterior, and you have to be careful here because T is not on the exterior of the circle or the interior. It is on the circle. So X would be the only exterior point. Now, I've got a theorem today, and it's the first one we've had in a while, so let's read through it. It says, if a line is tangent to a circle, so if we have a line like TX, then it's perpendicular to the radius drawn to the point of tangency. So if I come in here and I sketch this line, the radius that goes from the center to that point of tangency, it's automatically congruent with the tangent line. So it's going to help us have some right triangles. So let's look at this equation here. It says we've got circle C, and it has tangent, and it's a segment this time, AB. It says find X. So what it happens is they've made us a triangle in here. But what we need to remember is if we have a radius here, and it's touching a point of tangency here, that it made a right triangle. Now, I don't know if it's 30, 60, 90, or 45, 45. I don't know any angles except for that right angle, but that helps me use some things to find CA. This distance we can now find. It wants us to find just this right here, but I think we're going to need that first. So we can use Pythagorean theorem, but be careful, we're finding the hypotenuse, the C. So 5 squared plus 12 squared equals C squared. Remember, we're not finding X yet, we're finding the length of that whole line. Well, that's 169 equals C squared, so it looks like C is 13. But I don't need that whole side. There's one other thing I do know, though. This much of the line is a radius, and I know the radius is 5. So if the whole thing minus the radius should give me X. So 13 minus 5 will equal X, which means X equals 8. So it's kind of tricky. You got to think about some pieces. These are sort of puzzly because it wasn't just asking us for one piece of the triangle. It was a piece of a triangle. So be really careful when you look at that. And if you have any questions, just let me know tomorrow. The second theorem we're going to look at. If two segments from the same exterior point are tangent to a circle, then they are congruent. So what it's saying is, I'll just try to draw a little picture. You don't have to draw this. If I've got a circle and I've got this one point out there, and there's a tangent line, two tangent lines coming out from that these pieces are congruent. So from the point of tangency to there, the same length. So here's the example right here. I've got this exterior point P that has a tangent going to point Q and another tangent going to point R. If that happens, those segments are congruent, and you set them equal to each other. And now we can solve for X. So I add 3 to both sides. I get 2x equals 30. Divide both sides by 2, and I got that X is 15. So another one, these are pretty easy. You really want to be able to spot those two tangent lines to an exterior point. Let's go to the next page. Now this one's kind of tricky, but it's got a little, well, before we get there, I guess I forgot about this. When circles are inscribed in polygons, the polygons are said to be circumscribed polygons. In such polygons, each side is tangent to the circle. So what they're telling us is about this picture. We have a circumscribed polygons because there's a circle inside of it, okay? And it's told us some things about it. It says triangle TRW is circumscribed about circle A. If the perimeter of TRW, so the perimeter of the whole triangle, if P equals 50, TK equals 3, so I'm going to find TK, and I'm going to label it with 3, and WM is 9.5, they want us to find TR. So this whole length right there. Now, we know some stuff, because if I look at this circle, if I just look at K and L, those are both points of tangency with T as their exterior angle. So that means these two pieces are congruent, so I know part of what I need. I know the same thing over here, that WM and WK are going to be congruent. So this is also 9.5. The only thing I don't know is L to R and M to R, but they're in that same situation with the exterior points, so they're congruent. So I'm just going to call them both X. That's what we're looking for right now. Now I kind of have a placeholder for all the sides in the perimeter, so I can add them all up. So I have 3 plus 3 plus 9.5 plus 9.5, and then plus the two things I don't know. Now when I add those up, I should get the perimeter, which equals 50. So I'm going to combine my like terms. Let's see, 3 plus 3 is 6. 9.5 plus 9.5 plus 6 would be 25. Plus the two x's equals 50, which means 2x equals 25, which means that our x looks like it's 12.5. Now remember, they didn't want x. They wanted the whole thing from T to R, but now I know both pieces, and I can just add them together. 3 plus 12.5 will give me 15.5. So I know these are kind of weird, but if you just take your time and look for those little clues with the tangents, it'll make it a lot easier. Last one right here, and this one's actually pretty quick. It looks like it's a lot, but it's not. It says, given that O to A, that big thing there, is 12, that O to B is 6, I'm going to go ahead and fill that in there, and the measure of angle BAC, this whole angle right here, is 60 degrees. They want us to find all those things over the side. But let's talk about these because they gave us more than they show. It says from O to A, it's 12. Well, so that's this whole line right here. But we already know how long this line is because it's a radius. I'm going to go ahead and put that that's 6 also. Well, if the whole way from O to A is 12, then E to A must also be 6. The other thing here is we have these angles, and they told us this whole thing was 60 degrees. But when you cut it in half like that, it gives us 30-degree triangles. Now, let's use that, and let's see if we can answer some questions. So first, it asks for O to C. Well, O to C is a radius. It's going to be 6. We don't even have to look at the next one very hard. E to D is the diameter. Well, the diameter is twice the radius, so I got 12. Now, A to B and A to C are probably the hardest ones. Okay, you have to know something first. I have a radius and a tangent line. I know that's perpendicular. I have that on both sides. Okay, so now I have a 30, 60, 60, 90 triangle. Well, across from 30 is my x value. Across from 60 is my x square roots of 3. So I have 6 square roots of 3 from B to A. From A to C is the same as B to A because they're tangents from A. It's also 6 square roots of 3. I'd ask some pretty easy questions now that we have filled out. Angle BAO, we already have that labeled as 30 degrees. Let's see, OCA, this one right here is 90 degrees. AOC, we have labeled as 60 degrees. EOC is also 60 degrees. Then it wants the length from E to A, which we filled in earlier right there, which was 6. Now, I know this is kind of tough, and I won't be here on Friday, but any questions that you have, and the same thing goes for 4 or 5 when you watch that one, just have them ready Monday, and we can go over anything you need to. Good luck.